Hey, it is 2 hours UTC, and therefore it's time for another live stream of Astronomy Daily Live. Hey, everybody, hope everybody's doing good. You can call me Cosmic, and here we are again, gathering the circle of friends around for a daily conversation regarding the passion we all share for the science of astronomy. And hope everybody's doing well. Hope your past day/evening was well. Welcome to everybody coming in live. Howdy to everyone who is watching this later. I'm going to sort of do my usual things here. Get the get the chat up on the Linux machine. Dun, 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 dun. Let's see here. Dun, 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 dun. So after last night's live stream, I did go back out to take my chances with the clouds, and actually for a little while there, it was kinda kinda hard to tell whether um, whether there were clouds or not. When I first went out after getting done with this live stream, looked at Sirius and Betelgeuse, and definitely noticed a little bit of fuzz around the star. So that was definitely a sign of some high clouds. But then after a little while, that seemed to go away. I actually could see um, the Milky Way. I could definitely see clouds lit up by the couple of small towns around me. Um, so yeah, there were clouds definitely in the area. I did not let that deter me too much. There was a little bit, I mean, right as I said, right when I went out. Hey there, Bob Dog. How's everything going? Hope everything's well. Um, yeah, right after I got out last night, saw that um, fuzziness around all the stars, and it's like, no, this isn't going to happen. I'm not even going to do an alignment um, or anything because there's just absolutely no point in doing that. And then it seemed to sort of clear up a little bit. So it's like, oh, okay, I'm going to do an alignment, and uh, I did for the second time what I hoped I would never do again. So you can't see it on the scope now, um, but I've got a little finder scope on the side, that allows me to point, and uh, there are three there are three dials. There are three dials on that finder scope. There's one near the front that uh, moves the finder scope, left and right like that. There's a dial in the back, sort of on the bottom, that allows me to move the finder scope up and down like that. And then there's a dial sort of in the middle, which is the on and off switch, and also to change the brightness of the little uh, uh, red spot that it projects onto the sky. And uh, I've done this before, and I did it again last night. Uh, I grabbed the wrong dial because I wanted to turn the little um, red spot off, right? Little thing off, and I grabbed the wrong dial and I turned it, and it's like, man, that's the wrong one. And I'm dealing with a very, very, very small field of view in my CCD camera. It's like 12 arc minutes by 8 arc minutes. So it's less than a quarter the size of the full moon. So it's a very, very, very small patch of the sky. And so the alignment of the finder scope with the main scope has to be pretty darn close in order to be able to see uh, uh, um, my target in the field of view of the CCD. And when I turn that wrong dial up in front, I'm like, oh man, I'm screwed. Okay, um, because see, the only way that I can do an alignment between my finder scope and the main scope is to put an eyepiece on there, right down there. Put an eyepiece there, and it actually look, because otherwise I don't know where I'm pointing, right? So I need a little wider field of view in order to um, do that, and so what that required was taking the CCD camera off of the scope. I had it mounted in the same place, and um, the problem with doing that is once you change the configuration of your system, all the flats that I'd done essentially become null and void. They become just garbage uh, because um, the system has changed a little bit, and flat field measures not only um, the sensitivity of the CCD camera itself, but it also measures the sensitivity of the entire optical system. And so, any pieces of dust, any kind of strange um, um, optical artifacts uh, are recorded on the flat field. So if you change the geometrical configuration of your camera, then everything's changed. And so, you know, as soon as as soon as I realized what I'd done with the um, finder scope, it's like, all right, I'm totally screwed now. Totally screwed. I'm not going to be able to do what what I want to do. So I really didn't want to take that camera off of there. So I spent the next very long period of time uh, trying to point the scope, uh, essentially, with no um, finder at all, and it just doesn't work because I really didn't know which way I turned it, how far I turned it. I didn't know how far off I was. Um, Looking through the finder scope, of course, I can still see the red spot, but where it is in relation to my target, and that target, of course, has to lie in that very, very small field of view on the camera. I didn't know where that was, but it was it it's so important to not change the configuration of your system once you have a flat field, that it's like, okay, I'm gonna try to do everything I can to figure out this. And so spent an inordinate amount of time trying trying to figure out that. felt I felt like a uh, you know somebody who doesn't know anything at all. It's just, I mean, I was just I'm yelling at myself out there. It's like, can't you figure this out? can't you work this out, you dummy? But no, after too long of a time, it's like, okay, clouds look like they're rolling in anyway. So I think what I want to do is sort of change um, the program around, do something else instead. So at that point, it's like, okay, pull the camera off, put an eyepiece on there, find your stupid target, align uh, align the finder scope again, put the take the eyepiece off, put the camera back on, and then proceed from there. And so that's what I did. And after that, the alignment took just a few more minutes, and all was well there. But it's just just a frustrating, simple, very simple mistake can literally ruin uh, your entire night because I mean, if it would have been clear and um, you know pretty sure that I wasn't going to be doing any observations at all. Um, but if it would have been clear, probably I would have kept trying that until I got it. Eventually, you have to, right? Eventually, you have to, and yeah, I can be pretty persistent and um, stubborn about those kinds of things when I have to. So uh, basically, the thing that I did last night was uh, um, some telescope alignment tests. I wanted to see, uh, and this is just sort of an academic thing. It's not really vital to um, the operations or anything else. It's just sort of let's see what this does. And so what I did is I instructed the telescope to um, point to the same place several times. So I chose M41 again, so I could do the astrometry on it as well, using astrometry.net, which is an awesome site, very awesome site. Seems to work really well. Um, so happy with that. But yeah, I wanted a nice rich field of stars, and you know uh, those those were a known set of coordinates that didn't change, right? If I tell it to go to M41, it's going to go to the same right ascension and declination each time, right? So at least what it thinks is the same one each time. If the pointing is off, then it's not actually going to point to um, to the same place. So I wanted to see how accurate the pointing was and how consistent or precise the pointing was. And I already knew pretty much what the answer was. Hey there, Tom. Nice to see you in the chat again. Hope everything's well. Just reviewing last night's fun. Um, so yeah, so what I did is I told it to go to M41, and then I wrote down the right ascension and declination for my notes. And then as soon as it stopped slewing, I took a picture, right? Then, once the picture was taken, I manually slewed the telescope way far off, right? So, moved it off to some other part of the sky. And then I told it again to slew to M41, and it zoomed in. As soon as it stopped, took another um, um, picture. So I did this. I don't like 9 times, 8 or 9 times, something like that. Um, so I could get a measure uh, of the accuracy of the pointing and also on the precision of the pointing. And as I said, this was just sort of a academic thing. I knew the clouds were around, so I wasn't going to be able to do photometric stuff. The astrometric stuff is a lot easier because it doesn't necessarily rely on um, the brightness of the stars. It just, of course, relies on the position of the stars. It's hydrogen hydroxide tonight. Cheers. So yeah, I did that like 8 or 9 times, and slowly watch the clouds rolling in. Um, Actually, they didn't start to roll in until a little bit later. But so yeah, I did this several times, and then this afternoon ran those images through astrometry.net to get the center um, of the field of view, the right ascension and declination of the center of those um, images. And what I found, and this is pretty consistent with what I've already seen, um, is that yeah, and let me get the actual numbers here, because I calculated it all out, of course. So, um, so I'm I'm pointing pretty consistently west and north, pretty consistently. In that, my right ascension, my east-west motion was off by 508 pixels, which is almost a field of view. I've got 700 and I want to say 792 pixels um, left and right. Uh, so yeah, that's almost an entire field of view off in right ascension, but my precision was only 20 pixels. So I was pretty consistently off by um, almost a field of view in right ascension. And in declination, I was also about a field off. I was a field north. I was pointing too far north, yeah, too far north, um, by 455 pixels. But my precision wasn't quite as good. Um, uh, so so yeah. So what that means is, right, is that when I told it to slew, sometimes it would point, well, almost always point really well in terms of right ascension, but it would it would um, vary a little bit in terms of declination. And as I said, I was off by about a whole field of view or so. So again, that's just sort of an academic thing. Um, if I were going for a particular target, um, then I would have a finder chart, and so I would know by looking at the finder chart that I was off, and I would know, of course, which way to slew. and all that, to get the target in there. So yeah, I guess the only other thing that I want to do for this is, pointing depends on the alignment model, how well that model um, is able to calculate positions in this positions in the sky. So depending on the model, maybe the pointing will change. So I'm going to do this at least one more time, just as a test to see uh, if the pointing changes in any significant way. As I said, I sort of noticed this, and so though those numbers really aren't surprising me all that much. Um, so I think the model is being pretty consistent. Um, so yeah, it's just a nice thing to know. It's not a big deal or anything else. All right, I've got a kitty up here who probably probably wants me to play doorman. Yeah, okay. When he jumps up and immediately jumps down, he's like, tapping me on the shoulder, going, "Come on, be the doorman." So, all right, I'm going to exit just for 10 seconds. I'll be right back. So yeah, because of the clouds, it was a unsuccessful evening, which I wasn't too surprised at that. And it looks like we're going to have clouds for at least a few more nights. But yeah, it will clear up eventually, and I'll be able to do photometric measurements that I want, and hopefully those numbers will come back nice enough to allow me to proceed. Hey there, Uncle Bill, uh, with this extremely exciting project that I've got planned, which can't wait to tell you about. Cheers. But I've got to understand how this thing works and how well it works. I don't, I mean, I've got two things, right? One, I've got an idea in my head in terms of how well I want it to work, how well it sort of needs to work in order to do the things um, um, that I want to do, right? But then there's also the measurements themselves, and so yeah, two things there. The astrometry looks really good, right? I'm getting subpixel astrometry. Um, some of the stuff I'm seeing, I don't think I have it on. I don't think I have that spreadsheet pulled up. No, I don't. But some of the astrometry, I'm seeing, you know, accuracy to within like a tenth of an arc second, um, plus or minus 3/10 of an arc second. So that's absolutely fabulous. I mean, um, uh, almost not realistic, because I have pixels that are um, really close to being 1 arc second on a side. So the, sort of the best I well really um, um, the best to expect there is about like half a pixel, maybe a quarter or so, and that's more or less what I'm seeing. I'm um, um, glad about that for sure. And the photometry, uh, I I've got to be able to feed this thing calibrated data. It's got to be fluxes that have been flat fielded and dark subtracted. And what I'm hoping to do there is better than 1/10 of a magnitude accuracy, and maybe plus or minus like a tenth. Um, if I can do anything better than that, I'll be good to go. So, and I'm pretty sure that I can get at least um, tenth of a magnitude photometry on there. I'd really like to get close to a hundredth of a magnitude, but that, well, I don't know. I don't know. We'll we'll see. I think in terms of precision, I think I should actually be able to get pretty close to that. But the accuracy, don't know yet. Don't know yet. But that will come, and yeah, looking forward to that. So cheers. Thought what I'd do tonight is go over to the Orion telescope website and just sort of look around uh, on on their site. One of the things that I would like to do is to be able to uh, uh, get sent these devices, do a review on them on on this channel, and then give them away. I think that would be really, really cool and really, really fun, and I think really popular. but but yeah, whether that's going to happen or not, I I don't know. I think I would be a pretty good reviewer. I mean, I can dive pretty deep when it comes to these things, but I just sort of thought that we we could go through the Orion catalog and see what we see. So you can see they sell different types of scopes, different kinds of mounts and tripods, various accessories, adapters, cables, books, flashlights, focusers. Let's see. Of course, different kinds of scopes. They've got the refractors, they've got the reflectors, and then different kinds of mounts, like a Dobsonian mount, different kinds of reflectors, like Cassegrains. They've got the computerized scopes where you just have to press a button and it just zip 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 zip, and there's all your objects to look at. Spotting scopes, guide scopes, so-called expert scopes. See, mounts and tripods. Okay. Accessories, yeah, we already covered that. Astrophotography. So they get into doesn't look like they're getting into CCD cameras, but they've got a bunch of um, astrophotography, of course, which is very, very cool. Astrophotography cameras, auto guiders, get into binoculars, different kinds of binoculars, big ones, small ones, compact ones, stuff on sale, et cetera, et cetera. So let's get into telescopes and let's look at the refractors. So these are the telescopes that use lenses to gather the light in and focus them to a particular spot. So let's see, can we, is there a way to zoom in on these? We'll just do this. So this they're calling the Orion Observer 2 70 millimeter equatorial refractor. So a couple of terms in there. So 70 millimeters, that's the diameter. Where'd you go? That is the diameter of this lens in front, 70 millimeters in diameter. And then the equatorial part is the mount. You can sort of see it's a funny looking mount. This axis here, this axis, uh, you normally want pointed exactly north, So it's got to be at this strange angle, which you can set, right? If you know your latitude, um, then you can determine what this angle is relative to the ground, and so you can set that relatively well. And it's called equatorial because um, at that point, if this axis is pointing to the North Pole, and this axis is exactly 90 degrees to this axis, then you're looking at the celestial equator. So it's called an equatorial mount. And on this, let's see, can we zoom in a little bit here? Yeah, we can zoom in a little bit here. Can we move this? Ooh, cool. So you can kind of see it here. You've got these two dials. You've got a dial here and a dial over here. This dial is you can turn, and it's on a worm gear that allows you to move the telescope um, uh, left and right. So along right ascension. And this dial over here is exactly the same thing. It's got some kind of worm gear in it that allows you to move north and south in declination. This thing is just looks like a lock screw, probably to keep this angle. See, this is the angle you're interested in here. And in fact, is it? Am I doing this right? Is this the? No, I think no, I think that's right. I think actually this axis. Yes. Okay. Scratch what I said before about this axis looking north. It's actually this. Let's zoom in a little bit more here. Oh, can we do that? Yeah. So it's actually this axis here, going from the center here out to here. That's what has to point north. And you can actually see, we zoom in even more? Yeah, we can. You can actually see on the telescope itself that there's these numbers that go from 0 to 90. Well, this is 0 degrees above the horizon, and that is 90 degrees above the horizon. So this is currently set to, it looks like maybe about 28 or so. So what you would do is you would set this angle to your latitude. That happens to be the elevation uh, of your North Pole, wherever you are. And so in this case, it's set right to 28 or so. And then, as I said, this axis is looking then due north. This axis is looking 90 degrees to that. So this axis is actually looking at the celestial um, um, equator. And then your telescope, of course, is able to swing around wherever it wants to go. So you've got two pivot points. You've got this thing, which can turn, go around like this, right? Sort of up and down. And then you've got the telescope itself that can sort of go left and right. And so in this configuration, if you have it set up right, if you rotate the telescope along this axis, you're moving in declination. You're moving north and south. And if you move the telescope tube itself sort of left and right, you're moving in right ascension. Phew. So this also has a little very, very convenient right angle viewer, and it has pretty much exactly the same kind of finder scope that I've got, which these don't magnify or anything. They just project like a little red spot onto a piece of glass here, and then when you look through it to your target, you can see that little spot. So that's that. That's basically how most of the refractors work. They have an equatorial mount, and they move exactly like that. You've got the little dials. Um, Looks like a pretty good tripod. It looks like you can extend this out if you want. It's all I can say is that the longer these legs are, the more wobbly it's going to be. So if you're concerned about that, you want these legs to be as short as you possibly can, which sometimes means that you have to kneel at the telescope. You have to kneel at the telescope. So yeah. So let's look at these other ones now that I've sort of given a brief thing. So this is just looks like just a different size. It looks this one is a little bit shorter. You can see it looks like it's exactly the same mount. It's just a different scope. So this is a 80 millimeter diameter lens. Why did it do that? And it looks like it's shorter. That's cool. Yeah, it's an f5. 5. So the focal length then is just the diameter of this times your focal ratio. So what? That's 400 millimeters. What was the other one? Let's see here. Let's see if it says what the focal ratio is. It's probably about f7. May not even say f10. So 700 millimeter focal length with a 70 millimeter lens means that it has a focal ratio of 10. So that's pretty cool. Just a shorter focal length on that guy, slightly larger field of view. Okay, so here's just a different kind of mount, the alt azimuth mount. So it's just exactly the same thing as the last one, except it doesn't have an equatorial mount. So you can rotate this scope around this axis here. What are you doing that for? Let's see if we can zoom in a little bit. So it rotates right here. And then of course, the tube itself can go up and down. So this is your azimuth, and this is your um, um, altitude. So yeah, just a different thing, slightly cheaper. You can get that scope for $70. That's not too bad. Same size as the first one. As a beginner scope, like for a kid or something, these are awesome. Awesome and cheap. You don't have to oblige yourself to large numbers of dollars in order to get these kids a going. These are just different scopes. Doesn't look like these. I don't know if these come with mounts or not, or if it's just the scopes themselves. Carbon fiber. So here's 115 millimeters, so that's a little bit larger. This has got it looks like a substantial mount, at least for the tube. Don't know what's going on there. Let's see, 6.6 triplet APO refractor or refractor. Automatic refractor with two elements, extra low dispersion, substantial 85 millimeter aperture, triplet objective features a rotatable 2-inch hyperdrive focuser. Okay. Hard carrying case. Yeah, okay. Yeah, it looks like these are just the telescopes themselves, not the tripod or the mounts or anything else. And they're one like, $1,800 for that thing. Wow, it better be really good. 80 millimeters. Here's a 62 millimeter. Here's 130. Here's another. Looks like an Altaz mount. Here's a computerized one. You can sort of see what those look like. This is also on what looks like an equatorial mount, but the only the only real difference here is that you've got a little um, computer in the paddle here, and you've got um, some motors up in here and over here to turn your two axes. So you don't have to. They don't have those little um, turning knob things. And yes, this is a weight. It's a counterbalance, um, just just to take um, stress off of the motors, because these can weigh a substantial amount, and so you want to be able to balance those things. If you have balance, then the motor can sort of work at its best. So that's just a computerized one, so you can cheat and just type in the name of your object and zip, go. So what do you need a finder scope for? I don't know. I'd be interested in knowing if this scope has a clutch on it, so you can release the motors and be able to manually move it. Um, let's click back on there and find out if it says anything about that. Probably not. But your short focal go to equatorial mount, and tripod supports refractor with strength to spare, multi-coated objective lens, go-to mount, contains a computerized database of over 42,000 celestial objects. Yeah, so it doesn't say it has a clutch. It probably doesn't. That's sort of Um, um, one of the problems that I've got with mine too is that it doesn't have a clutch. So I've got to, in order to move it, I have to have it plugged in. So that sort of sucks. What's this VX6? 1259. Okay, well, what's the most expensive one here? Let's see. 1500. The one we just looked at was 1500. The 1800 one was just the optics. So, interesting. Okay. Tabletop refractors for beginners. I think these are all included. So maybe they're calling these. Well, I don't know. Let's see. Tabletop refractors. Let's see if that limits. Okay, so this is a different set. It looks like pretty cool though. Pretty cool. Can't tell if that's equatorial or alt as. Bring the cosmos to your table. This little wonder telescope packs a big performance punch with its 80 millimeter aperture refractor optics and compact portable tabletop base. It looks like it's alt as. So it looks like, just a guess, that this bottom thing rotates and then the telescope tilts up and down. So it's probably altitude azimuth. Probably. Pretty cool though. Pretty pretty cool little refractors for sure. $150. That's not bad. It's not too bad for that. Refractor with Altaz, with go-to mounts, refractor telescopes for astrophotography. Let's look at those. Okay, so these are just the sort of the more expensive ones, I guess. I would think that these you would use as a guide scope if you're auto guiding. So this scope would actually be mounted on top of a scope like mine, and there would be a camera in the back, CCD or CMOS camera that would. Hey there, Paranors 001. Nice to see you. Just looking at some scopes tonight. So yeah, these would probably be used as guide scopes, and that's why they're saying they're for astrophotography. Put a CCD camera in the back here, some software running to feedback to the telescope mount to keep things tracking. Because the tracking is pretty good, but if you want to do a long exposure, for more than 2 or 3 seconds, if you want to do an exposure for an hour or so, you have to be able to guide, because the tracking on your scope just isn't um, good enough, and so you need another system here to feed back into the telescope mount to correct those little errors. So yeah, so that's what those are for. Yeah, I see. All right, well, cool. Let's look at these guys as reflectors. Of course, the reflectors use mirrors. And let's see, reflector telescopes for beginners. Let's look at those first, I guess. I sort of like the categories here. So it looks like, let's look at this first one. So this is a 130, it says a 130 ST, which probably means primary mirror millimeters in diameter. And you can sort of see that it's more or less the same kind of of mount. It's an equatorial mount. And again, it's got the little dials, the little doohickey dials here and here in order to allow you, to manually move things around. This again would be pointing north. This would be pointing towards the celestial equator, and then you can move your scope around from there. So yeah, they're calling it a 5.1 inch reflector. Pretty fast too. It's a 24-inch long tube. So yeah, that's about a, less than an f5 mirror there. That's not too bad. Cheers. So that's a nifty little scope, and for 280 bucks, not bad. Not bad at all. Let's see what else they call a beginner scope. As I said, I would like to eventually get into a position, to actually um, review these scopes. Have these scopes sent to me to review, and if I'm able to keep it, what I would do is I'd um, give them away. I think that'd be really really fun. So here's almost exactly the same thing, except it's just on an alt-az mount, kind of idea as before. These look well. Obviously, this is a tabletop, but that looks like a pretty cheap mount there. But it looks like this. It looks like this whole thing turns. This whole thing turns, and then the tube tilts up and down. Yeah, makes sense. Looks like there's a computerized one that they're calling for the beginner. 600 bucks. Yeah, that's not bad. Let's see what it is. 150 millimeter. That's about 6 inches or so. It's a nice looking scope. I should also mention, and maybe let's go back here and see. Let's look at all of them. Come on, Slowpoke. Yeah, it looks like all of these are Newtonian focus. So Newtonian focus, just as a refresher, I'll pull up this scope, which will make it really really easy. So what we've got is down here at the bottom is your primary mirror, and that is the 6-inch mirror that they're um, talking about. Up here inside the tube is a flat mirror, um, usually like an elliptical shape, set at a 45-degree angle. And so the light comes in from the sky, goes down through the tube, hits the mirror in the back here. This mirror, of course, is concave, so it bends the light, starts to focus the light back this way, but the secondary mirror is in the way, and it's set at a 45-degree angle, so it bounces the light up into the eyepiece, here, and we can zoom in on that. That's a that's a pretty scope. Oh, come on, come on, WTF? There we go. So yeah, you can sort of see, they have an eyepiece on here. Here's a focuser with focusing knobs and all that. You got a finder scope over on this side, which, yeah, I mean, I guess that's okay. This looks like it's a, is this an alt-az? It looks like it's an alt-as. So again, this part here is going to be turning, and then the telescope itself just goes up and down. But there are motors in here, and there's probably, most likely, some motors on the other side here. Um, so you can use this as a go-to scope. They've got the little paddle there, which has a computer in it, which instructs the motors on how to move. So that's sort of a higher end beginner scope, but pretty nice. Pretty nice. Newtonian focus. Newtonian focus. Tabletop refractors. Let's go into those. Let's see. Okay. More or less the same kind of thing. They've put little fancy designs on here. Really, really cute. Again, these are 6-inch. 114 is more or less 6-inch. Oh, here you can get a really, really good view of the secondary mirrors in there and how they're mounted. These vanes here, which hold, of course, the secondary mirror in place. Let's see if I can zoom in on that a little bit. Come on, don't be a pain. These things are sort of the primary cause of your diffraction spikes. Those nasty things. But this is a Newtonian focus as well. You can't see it in there, but that flat mirror set at 45 degrees is right in there, right in the middle. Focuser here, eyepiece, finder scope, pretty cool. Tabletop, alt-as mount. All these are alt-as. This one just happens to have a motor on it too. Pretty cool. Reflectors with alt-as mounts. More or less, we're seeing the same thing over and over again here. Reflector telescopes with go-to mounts. Again, two different kinds of mounts. Motorized, you have the alt-as, different sizes, different focal lengths. So here's an equatorial mount that uses a computerized reflector. That's kind of cool. Again, the same kind of thing. Just different sizes, more or less. Come with various accessories. That's probably a moon filter. Now what I'm looking for is a cloud filter. I want to filter out the clouds. If anybody comes up with one of those, let me know. Let me know first. But yeah, that's just moon filters there, to knock down the brightness of the moon a little bit. When you start looking at the moon through, any modestly sized telescope, the moon gets really bright. It actually hurts to look at it because it's so bright. And if you look at it that way for you know uh, sort of a long period of time, and then take your eyes away, you'll just see like this big black spot in your eyes. So yeah, stay away from that if you can. So here's some bigger scopes. It looks like 8-inch scope. 10-inch scope, all with the Newtonian focus, where you've got your eyepiece and your uh, focuser mounted on the side of the tube. So that just tells you that it's Newtonian in terms of the focus. Yeah, nice scopes though. Getting expensive. $1,000 for an 8-inch go-to. Not too bad. Let's see what else they got here. Reflector telescopes for astrophotography. Okay, let's see what they're talking about here. So these are, I guess these are just some very serious guide scopes. An 8-inch guide scope. Pretty impressive. Yeah, pretty cool. So you've seen sort of the alt-az mount. You've seen the equatorial mount. There's also what's called the Dobsonian mount, which is basically an alt-az mount, just configured in a slightly different way. This kind of mount sort of allows for pretty large scopes, pretty large. Let's see. Let's just go through some of these. You'll see hopefully sort of right away that all of these are Newtonian focus though. So all the eyepieces are sticking out the side of the tube. Oh, come on. That looks like a 6-inch. But yeah, the most interesting thing is the mount itself. So let's take a look at that. What's called the Dobsonian mount. It's an altitude azimuth mount. So this whole thing rotates down here, and then your telescope tube tilts up and down like that. But the kind of mount it is just called the Dobsonian. So that's what this is, a little 6-inch. Let's see what else they got here. Yeah, and some with free shipping. So here's a 6, an 8, a 10, and a 12. Basically all exactly the same except for the size of the primary mirror. Goes all the way up to 12. Here again is a 6, an 8, and a 10, and another 10. I don't know why that's called a plus. HiQuest XT10 Plus Dobsonian reflector. What is the difference? Let's see, the XT10 is very affordable, intermediate Dobsonian telescopes, a stable base, an included easy finder tube makes it easy to find, easy to move the telescope and find objects. It's 10-inch aperture, parabolic primary optics. Okay, so the XT10 Plus has an upgraded 2-inch focuser, sort of coarse and fine focus. Yeah, just a few extras on there. So an extra $200 and you can have a few of the extras. That's not too bad. So let's see, that's an 8i, 10i, 12i. So then we start getting into the truss tube telescopes. I guess the telescope, uh, yeah, so these are sort of the go-to Dobsonians. So they have some kind of motor. Let's just click on one here and see if we can see. So yeah, it's got to have some kind of motor that rotates it around. Come on, picture. Jeez. Some kind of motor down here, that turns it around this way. And then there's a motor inside here that tilts the telescope up and down. And then you've got your little control paddle there again, of course, to do all of that. That's kind of cool. So then we get into the truss telescopes, which is just a tubeless telescope. That's all it is. It uses these usually like pipes to attach this top part, which of course has the secondary mirror in it, and the bottom part that of course has your primary mirror in it and all your mountings and all that. So it's just um, in terms of storage, um, this is nicer. Maybe in terms of moving it around, it's nicer, especially since this is a 16-inch primary. When telescopes get big, they get really heavy, and so having not having this being a solid tube, that just lightens the load, makes it easier for the motors to move around. Um, Slightly more difficult to do the assembly on, putting it together, tearing it down. Little, a few more um, um, steps there because you got to put this whole thing together, right? Each and every time. But stores well, is lightweight, very cool. 3,500 bucks for a 16-inch scope that can track. That's not bad. Let's see. I'm just reading Uncle Bill's comment in terms of push to, not motors but sensors. The telescopes, I mean. Huh. Okay. 14-inch, 12-inch. Let's see what else we got here. I think that's it. Oh, no, there's a few more here. If you have aperture fever, then you're interested in looking for the biggest telescope you can find. I never acquired aperture fever because I've worked with some of the largest telescopes in the world, and so I don't have that fever. Build a scope Dobsonian. That's kind of cool. So you can buy a kit. It looks like maybe. Is that what these are? Perfect for the intermediate viewer that wants to navigate the night sky. Pick your favorite accessories to create a package that's just right for you. Well, that's cool. Okay. You can sort of build your own. That's neat. That's pretty cool. Okay. Then we have other kinds of reflectors, are the Cassegrains, and you can see right away that the focus, the eyepiece, is in the back now. So this this is the Cassegrain focus, as opposed to a Newtonian focus where your eyepiece is sticking out the end of the tube. Here you've got a hole in your primary mirror. Primary mirror is in the back still. I'm going to try to zoom in on that a little bit. Come on. Come on. Sometimes you gotta talk to these things nicely. There we go. So you still have, your primary mirror in the back. You have a secondary mirror up front. The primary mirror is concave. Secondary mirror is convex, but that reflects the light back down through the hole in your primary mirror, and then, of course, out to your eyepiece. So that's just a Cassegrain focus as opposed to Newtonian. In this particular scope, you can also see that it looks like it's a alta as well. So this part turns the whole thing, and then the telescope tilts up and down. Yeah, Paranor, it's all about money, isn't it? Doesn't that suck? Yeah, I hate that. I hate that part. But you know, if you've got a scope now, use it to its fullest extent. Even if you've got um, um, binoculars, whatever you've got, you'd be surprised how far um, you can push things. So, as I said, I never got um, the fever. So, big scopes don't really um, impress me much. I I understand, that you can see um, fainter objects, more objects, all of that, and that's very very cool. But uh, yeah, don't worry too much about it. That's my recommendation, at least. So let's see. These are the casts. I've already gone over my hour. Man, it goes fast. It goes fast, fast, fast. So these are um, just the telescopes themselves. It's a slightly different um, um, configuration of mirrors and lenses, more or less the same thing. Let's see, anything else here? I was going to do an object of the day, but now it's past time, and so far, so far, at least in my limited experience, there's always been a tomorrow. So I'm pretty much counting on the fact that that there's going to be a tomorrow, and maybe we can do an object of the day tomorrow. Um, I posted a couple of papers over on my Discord server. Take a look at those. Kind of interesting. Grinding your own mirror is really really fun, really really awesome. I worked for a um, um, master optician for about a year or so. Made um, um, lots of mirrors, tested them. It's yeah. I think in terms of satisfaction, um, if you can get really really good, you can have a really really top notch mirror. The trick is there's sort of two things that you want to aim for, right? Is that you have to have the right shape, right? You have to have the right shape. The second thing is that you want it to be super super smooth, as smooth as you can possibly do it. Most of the optics that you just buy in these scopes um, are what's called quarter wave um, optics, which means it's bumpy on a scale of like one 1/4 the visible wavelengths. So, you know, we're talking nanometers still, but if you can get 10th wave or 20th wave or 100th wave and get that curve super, super smooth, then you're going to reflect more light, you know, because more bumps there are, the less light you're going to actually get. So, so those are the um, two things, and yeah, it's hard, and actually the hardest part, really, the hardest part is getting the smoothness down. Getting a parabola, that's pretty easy, pretty easy. It just um, basically just takes a polishing technique um, or techniques, and that's not a big deal. It's getting it super super smooth. That's where a lot of the time is. But yeah, it's extremely satisfying, extremely. But as you say, um, 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 cost effective? Nah, not really, not really. Uh, but yeah, I'm certain you can still buy blanks and the compounds and instructions and everything else and the testing, uh, all of that. I'm sure you can still get that or make it yourself. Um, Satisfying for sure, for sure. But yeah, um, if you want to get on the sky, uh, just go buy it. It's a lot easier that way. So, all right, I'm going to get out of here. It is way, way, way past time. I definitely respect your time. I can talk astronomy all day and all night. So these these hour plus things for me just fly by. It's great fun. Glad you could stop in. If you're new to this channel, make sure to subscribe, hit the thumbs up or the thumbs down, whichever you prefer. Make some comments. I like to see those. I will respond, and share this video around. All right, I'm going to get out of here for now. Thanks for stopping in again. In less than 23 hours, I will be back, and maybe you will too. All right, I will see you. I will see you on the spin. All right, take care. See you tomorrow. Bye.